Hey everyone, welcome back. In our last video, we learned how to design or model the part seen here. In this video, we're going to learn how to manufacturing it using CAM software. So whenever you're ready, let's go ahead and get started. All right, so the first thing you want to do is to come on up here to design, and you're going to want to come down to manufacture. And I'm going to go ahead now and close my data panel. All right, so the first thing we want to do is always start a new setup here. So let's come on up here and start a new setup. All right, and what we're going to do now is we need to set up our G54 work coordinate system. So I like to select the back left corner here, okay? And the way we have it right here is the correct way. So let's imagine you're facing your part here. If you're facing your part, your Z, your positive Z should be pointing up, your positive X should be pointing to the right, and your positive Y should be pointing away from you, okay? And make sure you're in the back left corner here, just like seen here, all right? And if you don't get it, you can try fooling around with some of these options here to change it, all right? So for our stock size, we're going to come over here, we're going to select fixed size box, and we're going to set our width here to 6.25. We're going to select our depth to 3.25, and we're going to select our Z as 1.25, and we're going to offset it from positive Z, in other words, the surface of our stock. We're going to offset it a distance of 0.02. And let's go ahead and select OK. So it's important to remember that this rectangular block shape represents your stock material, or the material you're going to be making your part from. So when we specify the X, Y, and Z dimensions here, we're essentially telling the computer what size block of material we're going to be starting with. So most milling or machining operations always begin with a facing operation. And facing operations basically take a thin layer of material off the top of your material to make sure that it's perfectly flat. So to do that, let's go on up here to 2D, and we're going to select a face. And we're going to come on over here to our tool, and we're going to come to our mounting plate tool library, and we're going to select our 2.5 inch face mill here, okay? And then we're going to select. So what we want to do now is set our feeds and speeds. So let's go with a spindle speed of 4,000 RPMs, a feed, a cutting feed rate of 20 inches per minute, and I'm going to go ahead and change all of these to 20. Okay, and I'm going to go ahead now, and I'm going to come on over here to my geometry tab. And what I'm going to do now is I'm going to select the top of the part. Okay, and for my heights tab, I'm going to leave all of my default values the way they are. And now over here in my passes tab, okay, I want to set a couple values here. So my pass extension, I want a pass extension of 2 inches. Okay, this will extend our tool path out so that it enters and exits the stock or part 1 inch further out past the edges of our workpiece or stock. Okay, and for our stock offset, we're going to set this value to 0.25. And what this will do is it'll make sure our face mill will go over the part with 2 passes, and it will widen our tool path to ensure that the entire surface is machined flat. Okay. Now I'm going to go ahead and hit OK. And if you notice, here is our tool path. Okay. Now remember, we set our part 0.02 inches from the surface. So it's taking off 0.02 inches off the top, okay? All right, so now let's go ahead and simulate this. I'm not going to simulate every toolpath operation, but to get us started, I do want to simulate this one. So let's go ahead now and come on up here, select simulate. Okay, make sure that your stock box is checked. And remember here, we set our stock or pass extension here to 2 inches. So our tool is coming out 2 inches past our part. All right, and our stock offset is set to 0.25 inches. So we widened our tool path here to make sure that our entire surface gets machined. All right, when you're ready, go ahead and select play. And you can see we're taking off 0.02 inches off the top. Go ahead and select close. All right, so let's start our next toolpath operation. And our next operation is going to be a 2D adaptive. So we're going to select right here 2D adaptive. And a 2D adaptive is a roughing operation, and it's a very efficient roughing operation for going around features of a part. All right, not always, but it's usually around the exterior of a part or feature. So let's go ahead now and select 2D adaptive. We're going to go ahead now and select our tool. And we're going to select our 3/8 3-flute end mill here. So come over here to your tool library, and we're going to select our 3/8 end mill here. And go ahead and click on select. All right, and now, since this is a roughing operation, we're going to bump up our spindle speed up to 5,000 RPMs. We're going to set our cutting feed right now at 25 inches per minute. Okay. And we're going to come on up now to our geometry tab. And we're just going to select, okay, this bottom contour right here. All right, and now let's come on over to our heights tab. And what we're going to do now is our bottom height, we're going to set that to model bottom. Okay, and we're going to offset it a minus 0.01 inches. And what that will do is it'll bring our tool down while it's cutting the outside of our part. It'll actually bring the tool down minus 0.01 inches down below our part. And that'll be nice later for our second setup when we go to face off the remaining material there. All right, so now let's come over to our passes tab. We're going to set our optimal load to about 0.1 inches. And you always want about 20% of your tool engaged with the material. So your optimal load is like your step over. All right, and basically the rule of thumb is you want about 20% of your tool engaged with the material. So our tool's a 3/8, you could, or 0.375, 0.375 times 0.2, 20%, and we get a value right around this, okay? And then where it says stock to leave, make sure these values say 0.02 and 0.02 for both radial and axial stock, okay, thickness. And what this is going to do is it's going to leave material along the outside of our part, okay? Because this is a roughing operation. We'll come back later and we'll remove this material later, okay? So once you've got that, go ahead and select OK. All right, and you can see the following toolpath. All right, now let's start our third operation. So come on up here to 2D and we're going to select a pocket. And a pocket is basically a flat area of a part surrounded by walls, all right? And so let's go ahead and go with the same tool we used before, a 3/8 flat end mill. Same spindle speed, 5,000, okay? We're going to set our cutting feed right here to same thing as before, 25. Now let's come on over to geometry and we're going to select our pocket contour right here, okay? And then for our heights tab, our default values are fine. For our passes tab, all right, our maximum step over is going to be the same thing as before, 0.1 inches. All right, let's see here. Stock to leave, same thing. We're going to basically leave behind 0.02 inches of radial and axial stock. So what this is going to do is we're going to leave behind a little bit of material. This is a roughing operation. And a roughing operation, we always leave a little bit of material. And in this case, we're going to leave a little bit of material along the walls here and along the floor of our pocket. Okay. We're also going to check feed optimization. And what this will do is in our inner corners of our pocket, it'll slow our tool down just a little bit because in those corners, our tool is in more contact with the part. All right, and we don't want to eat up our tool too fast or have any issues. So what it does is it basically slows our tool down in some of these corners a little bit, okay? And let's see here, everything else looks good, so go ahead and select OK. All right, now let's go actually and simulate this tool path real quick. So come on up to simulate, make sure the stock box is checked, hit play, and it's gonna start doing its helical entry path. All right, and then it's gonna start, once it hits the bottom, it's gonna start widening its tool path out here. And remember, it's gonna leave behind 0.02 inches along the walls of the pocket, as well as the floor of the pocket, or the axial and radial depth there. All right, now let's go ahead and close that and start our next operation. And our next operation is going to be a finishing pass. So remember, we left behind that 0.02 inches of stock left behind. Now we got to go clean that up. And a finishing path, most of our finishing paths are going to be a 2D contour. So go ahead and select a 2D contour. We're going to use the same tool we used before, a 3/8 flat end mill. Okay, our spindle speed is going to be 3,000 this time, and our feed rate is going to be 20. So typically finishing passes have a little bit slower feed rate and a lower spindle RPM value. Okay, now let's come on over to our geometry and we're going to select the outside again because remember we gotta remove that material along that 0.02 inches of material we left behind along the outside of our part. Okay, now let's come on over to heights. We got to do the same thing we did before. We're going to set the bottom to our model bottom and we're going to offset it now a minus 0.01 inches. Okay, and our passes, make sure the stock to leave is unchecked and we're good. Okay, it should say 20 inches per minute. We're good. Let's go ahead and hit OK. All right, now we got to remove the stock that's left behind in our pocket here. And if you zoom in, you can actually see that 0.02 inches that we left behind on our walls and on our floor as well. All right, so now let's go ahead and do yet another 2D contour toolpath. So come on over here, select 2D contour, and we're going to use the same feeds and speeds we used before. We're going to use a 3/8 flat end mill, spindle speed of 3,000 RPMs, and a feed rate of 20 inches per minute. Let's go to our geometry tab. Okay, we're going to select that pocket. Okay, and we're going to come now over to our heights tab. These default values are fine. Let's go over to our passes tab now, and we're going to come over here, we're going to click multiple finishing passes. We're going to set that to 4. And we're going to use a step over now of 0.3, not 0.1 like we used before, because we're only removing a small amount of material. Okay, so since we're only removing a small amount of material, we can widen our step over, right? We're only taking off 0.02 inches, okay? And what this multiple finishing passes will allow us to do is it will basically allow us to come out from our walls and it will remove that stock left behind on our floor here of our pocket, okay? So everything else looks pretty good. Let's go ahead and select OK. And if you zoom in, you can see the finishing path here on our floor. Okay, so let's go ahead and simulate this really quick so we can see how in This time I'm actually going to go ahead and uncheck the stock, and I want to zoom in here, and you can see it taking off that 0.02 inches along our pocket floor, and then widening out to get that 0.02 inches along the walls of our pocket. Okay. All right, looks good. All right, now let's start our next operation. And our next operation is going to be a 2D chamfer. So we're going to create the chamfer scene here that goes along the top exterior of our part. So come on up, and there's two ways to make a chamfer. You can select, well, a 2D chamfer, or you can make or use the 2D contour option. Okay, I like to use the 2D contour option, so let's go ahead and select that. All right, and we are going to change our tool here. So come on up to select, and we want to select, let's go to our tool library, and we want to select the 5/16 chamfer mill. If you know a chamfer mill here, you can see that it has sort of this pointed tip. Okay, let's go ahead and hit select. All right, and we are going to use the same feeds and speeds as our 2D contour pass that we used before. So 3,000 RPMs, a feed rate of 20. All right, and for our geometry now, we're going to select the bottom contour here of our chamfer. Okay, our heights are good. For our passes tab now, we want to come down over here, make sure the finished feed rate says 20. You want to make sure the chamfer box is checked. And for our chamfer tip offset now, we are going to select a value of 0.02. This will move our chamfer tip slightly down past our line here. I'll show you guys here in a second, okay? Everything else looks good. Let's go ahead and select OK. And let's go look at our toolpath now. By selecting that chamfer tip offset, I'm going to zoom in. And let's go ahead and simulate it really quick. So what it did was if you zoom in, you can see how it just moved it slightly down past our chamfer here, which is good. You don't want the tip of your tool to be on your chamfer, okay? It'll create a burr, and a burr is like a jagged edge, okay? So I'm going to go ahead and hit close, okay? And as always, feel free to pause this and simulate each toolpath on your own. Let's go ahead now and start our next operation. All right, so for our next operation, we're going to do a drilling operation to make these countersink 82-degree recesses here. So let's come on up, and we're going to select drill. Okay, and we're going to change our tool now. So let's come on over to select. Once again, click on our mounting plate tool library and come on over here to our 3/4 inch countersink tool is what we want to use. Okay, and we're going to go ahead and hit select. All right, and for our spindle speed, we're going to set that to 4,000. And we are going to use a feed rate now of 10 inches per minute. Okay. And now for our geometry tab, go ahead now and select one of these, our cylindrical recess here, or our countersink holes, okay? And then go ahead now over here and check the select same diameter, and it will basically go ahead and now automatically select all 4 of our countersink holes here. Make sure it says optimize order, so it'll save a little time there. Okay, and that is it. Let's go ahead and select OK. All right, so now we got to make the through holes, the holes that go all the way through. And remember, these have threads on them. And so before we can tap or add the threads, we need to drill a hole all the way through. And the hole needs to be slightly smaller than the tap diameter. All right, so let's come on up to drilling again. We're going to do another drilling operation. And we got to select our tool. and we want to select a 13/64 diameter drill. Okay, so right here, go ahead and hit select. All right, we are going to use a spindle speed now of 3,000 RPMs and a feed rate of 10. Okay, and for our geometry tab now, we don't want to select the countersink holes like we did before. We want to select this cylinder right here, and then go ahead and check select same diameter and make sure it says optimize order here. Okay. Our heights tab is fine. Let's come on over now to passes or cycle, excuse me. And for our cycle type, we want to select deep drilling full retract. Okay. And we got to set our pecking depth now. So when drilling, metal chips can clog and obstruct the drill procedure here. So a pecking operation will create a tool path where the tool retracts as it enters the part. And this basically allows the chips to evacuate or come out. Okay, so we're going to set a pecking depth now of 0.2 inches. And we're good. Let's go ahead and select OK. All right, and for our next operation, let's go ahead now and do another drilling operation. And this time we're going to add the threads to our holes. Okay, so we've drilled the holes out with a slightly smaller diameter than our threads. Now we can actually go down and add the threads. Okay, so we got to change our tool to do that. So let's come on up to select and come back to our tool library. And we want to select the 1/4 inch right hand tap here. Okay, go ahead and hit select. All right, and for this particular operation, for tapping, you want to slow it down. We are going to use a spindle speed of 1,000 RPMs and a surface speed here of 65. Okay. So in the geometry tab, we got to do the same thing we did before. Come on over, find this hollow portion right here. And we are going to go ahead now and select the same diameter box we checked before and make sure optimize order is ready to go. Okay. And now in our cycle tab here, okay, we want to come over here and we want to select right tapping. Okay. And let's go ahead and hit OK. All right, and for our next operation, we're almost done with our first setup. We want to mill and machine out this slot seen right here. Okay. So come on up to 2D, and we want to go ahead and select now. Let's see here, slot. And we want to change our tool now. And when you're doing a slot, you typically find the tool with the same diameter as the slot. Okay, so we're going to come on over here to our library and the slot. Okay, when we designed it, we gave it a 1/4 inch, okay, thickness, or the slot basically is a 1/4 inch across. So we're going to select a 1/4 inch end mill, okay, and we are going to hit select. We are going to use a spindle speed of 3,000, all right, and we are going to set a feed rate of 10 inches per minute, and this is important. We also want to make sure that our ramp is at 10, okay, and our plunge is at 10. All right, and now let's come on up to geometry, and we don't want to select the top of our slot because we want it to go all the way through. So let's rotate our part over and we want to select the bottom here. Okay. And now something to take note of, okay, if we come on over here to linking, okay, you can change your ramping angle of this. So you can make it more aggressive, okay, you can make it less aggressive, you can change a lot of the fine details. Okay, so I'm going to go ahead now and select OK, and it's going to generate a slot toolpath here. And so you can see how it kind of zigzags down into our slot. And like I said, you can adjust some of these angles and stuff. All right. All right, and now for our last operation for this setup is the next thing we want to do is to engrave the text here, your name or whatever text you put in there. So come on up to 2D and select Trace. And we want to change our tool again, and we want to use that same chamfer tool we used before, the 5/16 chamfer with the sharp pointed tip there. So we're going to come back to our tool library, and we're going to select my 5/16 chamfer mill. Let's go ahead and it's got that pointed tip that we can use for engraving. Let's go ahead now and press select. We're going to set our spindle speed now to 3000, and we're going to use a feed rate of 20. Okay. And we're going to come on over here now to geometry. Now here's where it gets a little interesting is you got to select your letters. And be careful with the O's and the A's. Make sure you get the inner ones too here. So in the E's. So you got to get the outer and the inner feature here. And the R's too, I guess, here. So, okay. Now in our passes tab, once you've selected all your text, okay, go ahead and uncheck the chamfer box, and now we need to tell our tool how deep we want to engrave into our part. Okay, so let's go ahead and engrave it a distance of minus, we got to tell it minus because we got to go into the part, right, 0.01 inches. All right, let's go ahead and hit OK. And you'll see the toolpath here and the actual engraving here, okay? So go ahead and feel free to simulate it when you get a chance. I'm going to go ahead and move on. Okay, the last thing we need to do now is to remove this base, the rest of our material here. Okay, we need to do a second setup to remove. This portion is called the hat. Okay, and we need to do a facing operation to remove this little bit of material that's on the bottom of our part. All right, so to start our second setup, I'm going to go ahead now and rotate our part around. Okay, and I'm going to just kind of click off the screen, and we're going to go over here to setup, and we're going to do a new setup. Okay, and we need to set up our work coordinate system again, so we're going to select this back left edge. Okay, and we need our Z, just like we did before, we need our Z pointing up. Okay, and so imagine you're facing the part here in the machine. We want our positive X going to the right, and we want our positive Y going away from us. Okay, and our positive Z going up. And you can flip these and fool around with these until you get the correct work coordinate system. Okay, so now that we're good, let's come on over here to stock, and we're going to go to a fixed size box. Okay, and we're going to do the same thing we did before. We had a width of 6.25, and we had a depth of 3.25. Okay, and for our height now, remember when we faced this, we took off 0.02 inches. So we're looking at 1.23, okay? And for our position now, let's go, I'm gonna shift things around here. Okay, our part, imagine what's left of our part after our first setup, okay? It's not here, we need to move it down. So our model position now needs to be offset from minus Z, 0. Okay, and this thickness right here is the portion we still need to remove. So let's go ahead and hit OK now for our second setup. Okay, And when you're done, you hopefully have something that looks like this. Okay. All right, and for our first operation, for our second setup, we want to go ahead and face off that material. So we're going to come on over here to face, and we're going to come back to our tool library here, and we're going to select our facing mill again like we did in our first setup. So come back to mounting plate. Okay, select our 2.5-inch face mill. Go ahead and press select. Okay, and we want spindle speed here of 4,000 RPMs and a cutting feed right here of 20 inches per minute. Okay, in our geometry tab, we want to do the same thing. This represents the top of our stock. We don't want that. We want the top of, or the bottom of our part, I should say. Okay, and in our passes tab, okay, let's set our pass extension here to 2 inches and our offset value to 0.25 inches, just like we did in the first one. Okay, and let's go ahead now and check multiple depths. Okay, and we're going to use a maximum step down here of 0.05. Okay, so this will make multiple steps as we cut down through our part. Go ahead and select OK. And my computer is being really slow right now. Okay, so it's going to come down, and these are the multiple depths. This is what our 0.05 here that we're coming down and we're cutting and removing our material. And for our last operation for our setup 2 is going to be a deburring operation. So a deburring is that sharp jagged edges so after you face this off, you're going to be left with a sharp jagged edge along our exterior part here. So we want to just remove that with a 2D contour path. So we're going to come on over here. And we're going to select 2D contour. And we're going to go ahead now and do the select button here. And we're going to change our tool to our chamfer tool, okay? Our 5/16. We're going to come back to our mounting plate tool library and select our 5/16 chamfer mill again, okay? And then we're going to set our spindle speed to 3,000, our feed rate, okay, to 20. And then for our geometry, we're just going to select that edge that we want to deburr so it's not sharp and jagged and nobody gets cut, okay? And that's it. We're now just going to go ahead. Actually, I'm sorry, that's not it. We do want to do our chamfer tip offset here to 0.02 inches, okay? And then let's hit OK. Okay, when you're done, simulate everything. To simulate everything, you can only do one setup at a time. So click on setup 1. I'm going to flip my part around, okay? And real quick, I'm going to show you guys how to do this, okay? Click on setup 1 and just go to simulate, okay? And it's going to show all your tool paths. I like to check stock so you can see how everything comes together. Hit play when you're ready to simulate it. Okay, you can adjust the speed of your simulation here. Check your stats. How long is your overall machining time? How long is it going to take to make setup 1 or manufacture your first setup? Go ahead and hit close. Then do the same thing for setup 2. Okay, simulate the whole process. Okay, and once again, okay, take note of the machining time here, the statistics. Okay. All right, that'll do it for this video. I'm going to go ahead and hit close. Thank you so much for watching. I hope you guys learned something, and we'll see you next time.